This episode is brought to you by The Build, a new podcast from the guys behind Sincera, Mike O'Sullivan and Ian Myers. They built their company by figuring out clever solutions to a few important ad tech problems in their industry. And that's exactly what this show is about. Mike and Ian interview some of the smartest tech minds in the biz to hear about how they identified opportunities, solved their hardest challenges, and grew their businesses in the process. Listen to The Build with Mike O'Sullivan wherever you get your podcasts.
We intended to prove out that you could use CDR telemetry. So that is the structural telemetry that you obtain as a result of cleaning files and analyzing files and using that kind of data to build machine learning models. So we wanted to first prove out that end-to-end process. Some researchers in the past had proved that it could work to some degree, but there was room for improvement in the performance there. So effectively, the MVP there became, let's first understand which bits of telemetry, if any, can be used for this process. If so, how good can we get this? I'm Dr. Aqib Rashid. I'm the Applied AI Lead at Glasswall.
This is Code Story, a podcast bringing you interviews with tech visionaries.
Spent 6 months moonlighting.
There's nothing on the back end.
Who share what it takes to change an industry.
I don't exactly know what to do
took
next.
many goes to get right.
Who built the teams that have their back.
The company is its people.
The teams help each other achieve
Most
more.
proud of our team.
Keeping scalability top of mind.
All that infrastructure was
Yes, we've been fighting it as we grow.
Total waste of time.
The stories you don't read in the headlines.
It's not an easy thing to achieve, mind
Took it
you.
off the shelf and dusted it off and tried it again.
To ride the ups and downs of the startup life.
You need to really want it.
It's not just about technology.
All this and more on Code Story. I'm your host, Noah Labhart, and today how Dr. Aqib Rashid is helping you stop malware in its tracks, helping you adopt zero trust and protect your data.
Today's episode is brought to you by .tech Domains, and this one hits close to home. Back in 2016, I was building my startup and went hunting for that perfect .com and found next to nothing. So I did what every founder does, settled. Here's what I wish someone had told me. You're building a tech startup, just get a .tech domain. It instantly tells investors and customers what you're about. Don't overthink it. Secure your .tech domain today from any registrar of your choice. This episode is sponsored by Unblocked. Unblocked is the context layer your agents are missing. It synthesizes your PRs, docs, Slack, and tickets into organizational context that agents actually understand. So they make better plans, write higher quality code, use fewer tokens, and require fewer correction loops. If you're running Claude Code, Cursor, or any agentic workflow, Unblocked is worth a look. Learn more at getunblocked.com/codestory. This episode is sponsored by Mesmo. If your team is collecting large volumes of logs, metrics, and traces, but still struggling to get timely answers, Mesmo can help. Mesmo is an active telemetry platform that processes and enriches observability data in real time before it's stored or analyzed. That means lower data volume, lower cost, and faster root cause analysis across your existing observability tools. To see how it works, get a demo at mesmo.com/codestory. That's MEZMO.com/codestory. This episode is sponsored by BrainGrid. If you are building with AI coding tools, but your features keep breaking, you need to check out BrainGrid. It is the product management agent for AI builders. BrainGrid turns messy ideas into clear specs, tasks, and prompts that coding agents like Cursor and Claude can actually build the right way. Ship real software, not fragile prototypes. Start free at braingrid.ai. Dr. Aqib Rashid was born and raised in London. He spent a lot of time around computers and tech growing up, and his parents pushed him towards becoming an expert in a discipline and being a positive influence on society. But he maintained his balance in life by playing sports, which inspired him to want to lead a team in the future. But outside of tech, he is a dad to a 1-year-old boy. He enjoys spending time with him outdoors and finds that the real beauty in life is watching him grow up.
In September 2023, Aqib had completed his PhD around the subject of using AI to detect malware. His current venture was looking at how to implement this sort of approach into their products. Quickly, he got to work building a new product to detect malware in your files using AI. This is Dr. Rashid's creation story at Glasswall.
Glasswall is a company that has existed for a couple of decades now, actually. It's a cybersecurity company based in the UK and the US. And the expertise that our company has built up over time is around a technology known as content disarmament reconstruction. I don't need to describe too much the phenomenon of malware and malicious actors trying to get into your system and wreak havoc in your corporate network or wherever it might be. And one way that they typically do that is through files. So that could be PDF files, it could be Office files. And of course, files are the lifeblood of an organization, whether it's sent over email or Slack or whatever it might be. And what you'll find is that traditional cybersecurity technologies, when they try to detect whether particular files are malicious, they invoke signature-based detection, they invoke some kind of heuristics. Your traditional AV will do a decent job of detecting malware. But in certain situations, in certain environments, all you want is a clean and pristine file, and you can't tolerate malware at all. And sometimes you're dealing with so many files that you can't necessarily siphon them off and do this kind of analysis on them. So this is where CDR, or content disarmament reconstruction, comes into play, and this is something that Glasswall has pioneered over the last couple of decades. So this is where you take your file, you break it down into its constituent components, and you rid the file of any kind of malware that might exist there. You then try to bring that file back to the manufacturer's original specification, because we've developed an understanding of what a legitimate file should look like. So you decompose it completely, you validate the file, and then what you deliver to the user is a clean, pristine file which is completely free from any kind of malware. It conforms to the specification of PDF or of Microsoft for Office or of images or whatever. And it's a deterministic guarantee that the file is safe to use regardless of where it came from. And this all follows that zero trust principle or philosophy, which is that you don't trust any kind of files or anything that you interact with. You simply clean it, cleanse it, reconstruct it, and give it back to the user such that they shouldn't actually notice a difference. I joined the company in September of 2023. I think I should probably preface this with my background, which is in the security of machine learning and the application of machine learning and AI to cybersecurity. So I was completing a PhD, 23, on the topic of securing machine learning-based malware detection and malware prediction models. So what that means is using AI to detect malware. And what Glasswall was looking to explore at that time was building capability to detect malware from files. Because it's all well and good being able to cleanse the file and being able to provide that guarantee that the file is now completely safe, but it doesn't give you that insight as to whether the original file was malicious. And for some organizations or users, that might be quite useful. It might be necessary actually for certain types of enterprise customers as well. So that's where I joined the company, and we started working on a product that would allow you to pass in a file to a machine learning model, and the output would effectively be the likelihood of that file containing malware. So effectively, you're operating on different signals from the file in order to be able to arrive at a verdict or some kind of prediction as to whether that file is malicious. Obviously, my expertise, they all are in the cybersecurity ML intersection. So I was quite well positioned to be working on this problem at Glasswall when I joined a couple of years ago.
And so I'm curious about the MVP of that product, right? You joined the company, got quickly started building this new product. Tell me about the MVP. What did it look like? What sort of tools you're using to bring it to life? And how long did it take you to bring it to life?
The MVP at the time, it was, so before we actually landed on the specifics of this product, so for example, which kind of file types we want to target, what are the various non-functional and functional requirements, etc. We had to prove out the science of doing all this. So taking different pieces of telemetry and using that to train a machine learning model, and that model should then have the ability to reliably distinguish between goodware and malware. So the first real question we wanted to explore is what kind of signal would be genuinely discriminative. You could say that was the MVP phase in the research portion of this project or this product. We intended to prove out that you could use CDR telemetry, so that is the structural telemetry that you obtain as a result of cleaning files and analyzing files and understanding what's in files, and using that kind of data to build machine learning models. So we wanted to first prove out that end-to-end process. Some researchers in the past had proved that it could work to some degree, but there was room for improvement in the performance there. So effectively the MVP there became, let's first understand which bits of telemetry, if any, can be used for this process. If so, how good can we get this? Can we validate the hypothesis that do malicious files look structurally different from benign ones, given the data that CDR exposes? So what we found at that point was that the answer is yes. There is a statistical difference between the CDR data that represents malware versus the CDR data that represents goodware. So that is the deep structural telemetry that I referred to earlier. So then obviously you then have to try to figure out, okay, we've proved the science of this a little. Now we have to try and prove this out as an end-to-end commercially viable product. So commercially viable product means, okay, you can achieve specific true positive rates or detection rates, or specific false alarm or false positive rates to make this useful for customers, but equally aspects such as inference time or round trip time, the deployment requirements and all that kind of stuff suddenly come into play there. So the early phases of this at the MVP stage, when this transitioned from being a research project effectively into a product that we sought to develop at the time, involved making some deliberate decisions around the types of model architectures, the types of files that we would support, aspects related to explainability of models, because this product is intended to work as well as in a highly regulated, mission-critical environment, but also maybe in an enterprise SaaS solution as well. So you might not always have access to the internet. You might not always have the ability to call to home, so to speak. You'll have the requirement for transparency and auditability. When you're doing this at scale, you need to have the efficiency of millisecond scale inference. So making a decision on file in milliseconds. So that tolerance for sitting around and waiting for a file to come back with its verdict just isn't there at this kind of scale. So understanding all of these different aspects of what customers would want and what would uniquely position this in a certain period of time once we had developed this was paramount for us at that early stage. And of course, the different file types themselves, they are equally diverse, but also equally complex in their nature. So PDFs are radically different to Microsoft Word documents, which are different to Microsoft Excel documents, which are different to images. So we have to make certain decisions at certain points in this entire process to try and bring about a useful product on all fronts there.
This episode is brought to you by The Build, a new podcast from the guys behind Sincera, Mike O'Sullivan and Ian Myers. They built their company by figuring out clever solutions to a few important ad tech problems in the industry, and that's exactly what this show is about. Mike and Ian interview some of the smartest tech minds at Magnite, Chalice, DoubleClick, and LiveRamp to hear about how they identified opportunities, solved their hardest challenges, and grew their businesses in the process. This show is for you if you've had some of these breakthrough moments yourself, or if you're seeking inspiration for the next one. Listen to The Build with Mike O'Sullivan wherever you get your podcasts. Today's episode is brought to you by .tech Domains, and this one hits close to home. Back in 2016, when I was building my own tech startup, I went on the hunt for that elusive .com. Looked high, looked low, and guess what I found? Nothing. What I did find cost me an arm and a leg. So I did what every founder does under pressure. Threw in extra letters, settled for the less than optimal name. And here's what I wish someone had said to me back then. Noah, you're building a tech startup. Just get a .tech domain. Tech startup, .tech domain. It could not be more obvious. It tells investors, customers, and anyone who looks at your website, really, that tech is at the core of your build. And I've kicked myself plenty since. Especially when I see the clean and sharp names tech companies have landed on .tech. Nothing.tech, 1x.tech, Aurora.tech, CES.tech, Ultra.tech, Alice.tech, Neon.tech, Blaze.tech, Pi.tech. You get the idea. So take it from someone who learned it the hard way. If you're building a tech startup, don't overthink it. Secure your .tech domain today from any registrar of your choice. You've got that MVP, and you kind of touched on this at maybe at a high level, but I'm curious about how you progressed and matured it from there. What I'm really looking for is, like, how do you build your roadmap? How do you decide that, okay, this is the next most important thing to build or to address, in this particular product?
The maturation or that development process is all about taking it from the hypothesis to production discipline. So, of course, early on, it was all about ensuring and validating that the signal that we are training on here, which is that CDR telemetry that is produced by Glasswall, actually worked for the problem of detecting malware and predicting malware. But then taking it into production and maturing this further and building this into a roadmap basically meant bringing in that ML DLC, so machine learning development lifecycle, and the SDLC, and all the engineering rigor that comes with this. So that is looking at automated experimentation infrastructure, independent model assurance on specific data sets, ensuring that any models that you develop are tested reliably on threats that the model has never seen, building out continuous drift monitoring systems to understand if drift is occurring, how severe is the problem, but then equally building the software aspect of all this as well, because it's all well and good building the AI capability and the AI model and having a very robust process where you can ingest millions and millions of files as part of your training pipeline and train a model in a matter of hours, which is what we've done at Glasswall. But then you also need to make the output of that process, which is the model, usable and useful for the user. So building out a very user-friendly piece of software that ultimately gives customers that satisfaction that the model and the brains behind the operation, it is fundamentally going to make decisions about files in a manner that is safe, trustworthy, explainable, but then equally is understandable as well. So baking all of this into the roadmap and an understanding, of course, along the way that this could be a potential pain point for a customer, or a customer might expect this at this juncture, was pivotal. We had some great input from our product team at Glasswall along the way for understanding these different pain points. And of course, we were speaking to various prospects along the way as well. And I think it's important to get those early feedback loops in this process. With these feedback loops, with the understanding and the concrete understanding, I would say, about what we want from this product, but then equally the engineering rigor, so that strong, stable, maintainable process around building this product and these models, all of that contributed towards the ultimate roadmap here. The roadmap here isn't a case of, okay, build a model that can detect malware in every kind of file that exists out there. No, you have to build out products in a manner that is also sustainable. So that means first build a model for maybe the PDF file type, and then build a model for the next file type. And slowly you can start building up models in a repeatable fashion as well, once you've understood the methodology there as well. Yeah, an interesting thing nowadays, of course, is the developments we're seeing in agentic AI as well. So that has also had an impact on the roadmap. And of course, the industry is also rapidly evolving. So the industry and its evolution also factors into your roadmap as well, and it must do as you are developing a product like this.
So what about team? How did you build your team, and what did you look for to find, what did you look for in those people to indicate that they were the winning horses to join you?
So I looked for people who are genuinely curious about the problem and not just the technology, the machine learning frameworks and the actual languages and just different engineering tools, so to speak. You require that curiosity in order to be able to solve difficult problems. You want people who are eager to learn, but also eager to contribute at the same time. And you want people who hold themselves to a very high standard. That's why looking for the people who have, of course, the engineering prowess and the domain knowledge is absolutely vital, but also looking for people who are genuinely curious, as we did at Glasswall, is imperative when you're trying to solve a very difficult problem, as we have done with Foresight and with this product that can detect malware.
This episode is sponsored by BrainGrid. Building with AI coding tools is exciting until the moment things start breaking. You ask for a small change and suddenly 3 other features stop working. AI gets confused, misses edge cases, and loses track of your intent. The problem is not code generation. The problem is planning. That is why BrainGrid exists. BrainGrid acts as your product management agent. It writes clear specification, maps UX flows, asks the clarifying questions you forgot to ask, and breaks big ideas into engineering-grade tasks that AI coding tools can build reliably. It guides Cursor, Claude Code, Replit, Windsurf, and others so they deliver features that work and keep working. Founders use BrainGrid to build real AI-native SaaS products without a technical background. If you want reliable features instead of fragile prototypes, try BrainGrid for free at braingrid.ai. That's braingrid.ai. This episode is sponsored by Mesmo. If you're responsible for reliability, performance, or platform architecture, you already know the problem. Telemetry volume is growing faster than teams can manage it. Mesmo addresses this by moving observability upstream. Instead of storing everything and asking questions later, Mesmo processes telemetry in motion, filtering, transforming, and enriching logs, metrics, and traces before they reach your observability backend. The result is cleaner data, reduced ingestion costs, and faster root cause analysis using the tools you already rely on. Mesmo integrates with platforms like Datadog, Dynatrace, and open source stacks, giving teams more control without adding operational overhead. This is especially useful for platform engineers and SREs supporting complex distributed systems where context and speed matter. To see how active telemetry works in practice, get a demo at mesmo.com/codestory. That's mezmo.com/codestory. I'm curious about scalability, right? And where it came into play when you first joined and took on, this building this new product. I'm curious how you approached it in the beginning, but I'm really interested in where you've had to fight it as you've grown.
When I joined the company, there wasn't really an ML pipeline or an AI pipeline that had been used for experimentation and building models, because up until that point, a lot of the work was in the research phase and proving out the feasibility of training models with CDR telemetry. So when I joined, one of the first things that we did was build our ML pipeline from the ground up. So that involved a lot of AI engineering and a lot of discussion and thought around scalability. And I'm pleased to say that nearly 2 years later or so, we're still using that ML pipeline. We're still using that technology that we built that can, like I say, ingest millions and millions of files and conduct feature analysis, conduct feature selection, conduct model training, do all the post-training activities, and at the end of it, give you a model in a matter of hours for the file types that we care about. And being able to do this is no easy feat, especially when you consider the costs that could be involved in doing so. We've got the costs down quite considerably as well. But the ultimate beauty of all this, of course, is that we have models that will stand the test of time and they will scale with the evolving threats and with evolving malware as time goes by. So it wasn't the case that we were fighting with scalability or fighting necessarily as we grew. We knew ahead of time that we want to make this process of developing machine learning and AI models as repeatable, as automatable, as reproducible as possible, while also ensuring that there is going to be a high quality model at the end of this entire process as well. And this is just on the training and the ML side. So one could also consider scalability in terms of using the model at inference time. So that is deploying the model and giving it to a customer and letting them have a go of it and take it for a drive. It's important that at inference time as well, or at prediction time, the model behaves reliably and it scales well there as well. And it doesn't suffer from high degrees of latency where you're waiting seconds and minutes for a file's verdict to be returned to you. So all of these kinds of potential challenges we had thought of ahead of time with a view to ensuring that this product will be sustainable going forward.
As you step out on the balcony, you look across all that you've built thus far with Glasswall. What are you most proud of?
I think it's the fact that we have managed to solve a very difficult problem. If you look at academia in general, with respect to ML-based or AI-based threat prediction, they paint quite a bleak picture where they say that this is a very difficult problem and we don't think this will be necessarily solved because there are so many pitfalls and challenges involved, and you might be able to build a model but suddenly it will start drifting and it will have poor performance a month later as you get new types of malware in the wild. I think though with Glasswall and with Foresight, which is the capability that we've developed and the models that we've developed, we've shown that not only can you build models that can detect malware or predict malware on day zero, so that is looking at those unknown or zero-day vulnerabilities, but they will do just as well on day one when you know about the vulnerabilities that exist in the wild, but also months and months down the line where the threat landscape may have evolved, the types of malware that exist have evolved, but because we have trained models on deep CDR structural telemetry, what we are somewhat inoculated against is that evolving threat landscape. So it means that we have proved out that yes, you can build capable models for this problem, but then equally, you can then deploy these models in an air-gapped environment, in an offline environment where you have no call to home, you have no internet, and the model will work very well there. You can deploy this same model in a SaaS solution, maybe in some kind of enterprise network. It will work just as well there. And all the while proving out along the way that you can do this in a scalable, maintainable way, underpinned by the world-class R&D that we've done here at Glasswall. So that is the decades of file-based security research that we've done, the AI engineering and AI research that we have conducted, and of course, the intersection of those two fields has led us to Glasswall Foresight, which of course is undoubtedly the thing I'm most proud of in terms of my work at Glasswall.
Let's flip the script a little bit. Tell me about a mistake you made and how you and your team responded to it.
I think research and development in general, or science in general rather, is all about making assumptions and making hypotheses about certain problems or certain questions that have come to mind. And oftentimes they don't stick or they don't land as you'd expect. So for example, an assumption that we made early on in the R&D phase was that certain structural features might be more useful than others for the purposes of trying to detect malware. But what we quickly saw and quickly found was that where we were looking at certain structural features and certain telemetry, we weren't getting the results that one would expect and one would consider commercially viable. So that obviously means you then have to go back to the drawing board and think a little deeper about the problem. And of course, thinking further and further about the science behind all this and the research behind all this, will eventually get you to the right solution, because I don't think that there is any problem out there that is completely unsolvable. Problems are going to be very difficult and you will make mistakes along the way in trying to solve those problems. But that is all part of the learning process, Noah. I don't think there's anybody who can claim to have developed a perfect solution the first time around.
This episode is sponsored by Unblocked. Your coding agents have access to your code base. Maybe you even connected other tools via MCPs. But access doesn't mean context. Agents can't reason across MCPs. They don't know your architectural decisions, your team's patterns, or why the API was shaped the way it is. So agents look in the wrong place and deliver bad outputs. Then you spend time correcting. More loops, more tokens. Unblocked is the context layer your agents are missing. It synthesizes your PRs, docs, Slack, and tickets into organizational context that agents actually understand. So they make better plans, write higher quality code, use fewer tokens, and require fewer correction loops. If you're running Claude Code, Cursor, or any agentic workflow, Unblocked is worth a look. Learn more at getunblocked.com/codestory. Okay, Aqib, let's move forward. What does the future look like for Glasswall? For what you've built there, for all the things, how are you moving forward as the industry's changing regularly? What does the future look like?
Our work at Glasswall is a cybersecurity company, as a company who is heavily focused on file-based security and ensuring that the safety of our customers is obviously going to be underpinned by the evolving threat landscape, which is predominantly these days about AI and the threats posed by AI and the agentic ways of working, so to speak. So that means developing capability in this kind of new era, whether it is dealing with AI-based threats, whether it is dealing with new types of malware or new customer concerns around AI, but in equally ensuring that the capabilities that we have developed to date remain as effective as they've ever been, because cybersecurity in general is a field where it is extremely critical to keep up to date, and it is extremely high stakes, and you can't afford to make mistakes. So what I would say is that the world of AI, the world of cybersecurity, these are probably two of the hottest places to be as a company, and we are in both. And in fact, we're at the intersection with Glasswall Foresight, with content disarm and reconstruction. Stay tuned, I would say. There are certainly some very interesting developments coming out. One of them, of course, like I say, Foresight, which we have actually launched today. So that is extremely exciting, and I'm looking forward to seeing that ending up in the customer's hands and understanding where customers want us to look further at in terms of any kind of AI capabilities going forward.
Okay, Aqib, let's switch to you. Who influences the way that you work? Name a person or many persons or something you look up to, and why.
I think I generally look to the security and AI community in general, in terms of the evolution that has happened over the last 20, 30 years, and the influence that has had on me as a person, and the impact that has had on my ability to gain knowledge, to disseminate knowledge, and then equally to make this as applicable as possible. So that is the answer in terms of industry knowledge and academic knowledge, so to speak. But generally speaking, I've had some really great role models growing up. My parents, my father, who pushed me towards pursuing a PhD in the space of computer science. And that was, of course, a great influence for me growing up. So I think that certainly influences the way I work, because I've always been pushed towards that drive for excellence and that drive for perfection where it is reasonable. But it's not always necessary that you need to arrive at a perfect solution every time. But that drive towards excellence is absolutely essential. And that's effectively what's been influencing me, and it still continues to influence me to this day.
Okay, last question. So you're getting on a plane and you're sitting next to a young entrepreneur who's built the next big thing. They're jazzed about it. They can't wait to show it off to the world and can't wait to show it off to you right there on the plane. what advice do you give that person? Having gone down this road a bit and building this new product at Glasswall, what would you tell them?
So I would suggest to any young entrepreneurs is to build something that deserves trust before you build something that seems to be impressive, but somebody could potentially copy overnight and somebody could get to much quicker than you. But for example, an analogy in cybersecurity and AI in cybersecurity is that it's very easy to build an AI model that looks good on a benchmark, but having that model then do very well in the real world under adversarial conditions is a very different problem. And I think that translates to pretty much anything else. So get that early feedback, get that validation from prospects and customers and people who know more than you before you try to build the perfect solution for a problem that might have been solved already, might not exist, or somebody might have the capacity to do better than you. That is a fundamental aspect in the way of working these days with the rise of AI, is that it is very easy now to build products very quickly. And along the way, of course, you will make mistakes and things will go wrong. But the question then becomes is, do you have the fortitude and the resilience to stand up and to say, no, I'm not giving up here. And instead, I'm going to spend some time, energy, effort, and some brain power to either fix this, remediate it, or just to build something better. I think that is important. So seek validation, seek that trust, and don't try to build something which is going to be unsustainable. And certainly don't go for a problem which is effectively going to be solved by an AI agent in virtually no amount of time compared to you. So spend your time as wisely as you possibly can is what I would say.
That's excellent advice. Well, Aqib, thank you for being on the show today. Thank you for telling your creation story at Glasswall.
Thank you, Noah. It's been great.
And this concludes another chapter of Code Story. Code Story is hosted and produced by Noah Labhart. Be sure to subscribe on Apple Podcasts, Spotify, or the podcasting app of your choice. And when you get a chance, leave us a review. Both things help us out tremendously. And thanks again for listening.
Capital One's tech team isn't just talking about multi-agentic AI. They already deployed one. It's called Chat Concierge, and it's simplifying car shopping. Using self-reflection and layered reasoning with live API checks, it doesn't just help buyers find a car they love. It helps schedule a test drive, get pre-approved for financing, and estimate trade-in value. Advanced, intuitive, and deployed. That's how they stack. That's technology at Capital One.